Okay, everybody, and welcome back to Advanced Algebra 2. Today, we're going to be talking about something called a piecewise function. Now, we are on page 17 in your workbook. So starting on page 17 in your workbook, we can take some notes. And the first thing that we want to do is we want to write down what a piecewise function is. So verbally, what a piecewise function is, a piecewise function has different rules or different formulas for different parts of the domain. So one piecewise function might have two different rules. It might have 3 or 4. There could be a whole bunch of different rules for each part of the domain. So here's what the equation, or what an equation of one would look like. You might see something like this. F of x equals 7, comma, -5, less than or equal to x, less than or equal to -2. Or you might see 5 minus x if -2 is less than x, less than or equal to 3. Or you might see 2x minus 1 if 4 is less than x, is less than or equal to 6. So this is what a piecewise function might look like. This piecewise function is actually broken up into 3 different pieces. So the first line is one piece, second line is another, and the third line is another. And so what this is it's a different formula for each part of the domain. So I'm going to look at this top line. The top line is one formula, and the formula of 7 only applies on the part of the domain that lasts from -5 to -2. 5 minus x is a formula for this function, but it only applies for when the x values are between -2 and 3. And then 2x minus 1 is a part of the function, but it only applies for when the x values are between 4 and 6. So let's look a little bit more at that. We're not going to write any more notes on this page. In fact, we're not going to do all the examples from 1-3. We're only going to do a few of them. So turn the page and look at example 1, and we're actually going to change what example 1 is. So we're going to, and if you were in my class, like we would still, you would have your workbooks, and I would say, all right, everybody, let's mark out these words because I don't like this example that much. We're going to do a different example in its place because actually they didn't even give you all the information here. Okay, so instead of that, what I'm going to ask you to do in example 1 is I'm going to ask you to evaluate the function. And then we're going to do 3 different things, or maybe just, 3 different things. I want you to evaluate the function when x equals -4, when x equals 0, and when x equals 5. Actually, not 5. Let's not make it 5. Let's make it 6 when x equals 6. Okay, now what function? Well, we need a function. So we're going to write down the function, and here's the function. F of x equals, this function has 3 parts. It's the same one that I wrote down on the other page, but I'm going to color code it a little bit differently. So f of x equals, now our first line is going to be 7 if -5 is less than or equal to x is less than or equal to -2. The second line of the function in blue is now 5 minus x if negative 2 is less than x is less than or equal to 3. And then the third, I'll make that one in purple, is going to be 2x minus 3 if 4 is less than x is less than or equal to 6. And we have to do three things. We have to find, evaluate the function when x is negative 4, when x is 0, and when x is 6. So let's evaluate the function first when x equals negative 4. Now, my function has 1, 2, 3 lines. I need to know which line I need to use. In other words, for this function, which formula, 7, 5 minus x, or 2x minus 3, which formula applies when x equals negative 4? Well, negative 4 fits into this domain because negative 4 is between negative 5 and negative 2. So when x equals negative 4, then f of x, or f of negative 4, equals, and there's nothing to substitute that negative 4 into, f of negative 4 equals 7. So I'm going to use this line anytime I'm given an x value in between negative 5 and negative 2. Okay. The second thing I have to evaluate is they want me to evaluate the function when x is 0. So x is 0. I need to figure out from these three lines, where does 0 fit? Which category does 0 fit into? Is 0 between negative 5 and negative 2? No. Is 0 between negative 2 and 3? Yes. So I will use this formula because that 0 is between negative 2 and 3. So I will come over here and say that f of 0 equals, and I take the formula 5 minus x and substitute in a 0 for the x. So 5 minus 0, which is 5. Okay. Finally, when I evaluate the function when x equals 6, that means what's the value of the function when the input is 6? So I have this last line that I'm looking at. I haven't used it yet. Is this 6 within the domain of 4 and 6? Yes, because this last line includes the value of 6. So I will use this formula, or this equation, or sorry, this line to evaluate f of 6. So f of 6 equals, I'm going to use the formula 2x minus 3, but we're going to substitute in a 6. 2 times 6 minus 3 equals 12 minus 3 is 9. Now, what would happen if I were to say if I were to evaluate the function when x equals 10? Well, 10 does not fall within any of these domains. 10 is not between negative 5 and negative 2. 10 is not between negative 2 and 3. And 10 is not between 4 and 6. So the value of the function when x is 10 is undefined. So if you were to be asked a question like, hey, what is f of 10 for this function, you would say undefined. Okay? All right. In our next video, I'll show you how to graph piecewise functions.